And this is going to be a brief recap of testing for symmetry for quadratics and then testing for symmetry in general. So for quadratics, we had two things to look at. One was called vertex form, and that was y equals a times x minus h quantity squared plus k. The axis of symmetry, which is sometimes called the line of symmetry, is x equals h. So some examples of finding the axis of symmetry or the line of symmetry. If we have this function here, all I'm focusing in on is what's with the x, and if it's with the x, it's going to be the opposites. The axis of symmetry is going to be 5. The vertex of this thing would be 5, 2. If it's this second one here, again, I'm just going to be focusing on the what's with the x. It's the opposite of what's with the x, so the axis of symmetry would be -3, and your vertex would be -3, -1 if you were to graph it, and that's where it's going to be symmetric. So quadratics in vertex form, you just need to get the x-coordinate of the vertex. Okay. If you're in standard form, ax squared plus bx plus c, the axis of symmetry, or the line of symmetry, is the same thing as the x-coordinate of the vertex. And you've done that a bunch. So I have one example here where I find the axis of symmetry, the line of symmetry. It's a negative b over 2a. So it'll be negative 3, which is positive 3, over 5 times 2, which is 10. Okay? So the important thing is as you're preparing for this next exam, is they're just going to say, tell us about the symmetry. Does it have y-axis symmetry, origin symmetry, or might just say symmetry in general. And it depends on what it is. If it's a quadratic, this is what you need to use, either vertex form or standard form. Okay, you know how to do that. It's just you need to pay attention to the directions. Okay, the other thing is if it's just a general function, is if we're going to test for symmetry, we have the even or the odd. So this is for non-quadratics. So testing for non-quadratics. So you're an even function if f of negative x is the same thing as f of x. And this is, we would say that these are the same. And I'll draw you a little bit of a picture. So there's negative x and x. F of negative x is the same height as f of x. And you see that they are symmetric with the y-axis. You're an odd function if f of negative x is equal to negative f of x. So that would be opposite. So here we put x in. Here's f of x. Okay, then there's negative x. And f of negative x is at the same height as f of, or negative f of x. And you have your origin symmetry. And we'd call this one opposite. Okay? So in both cases, you're plugging in negative x in place of x, and you're going to decide whether the function is the same, is it exactly the opposite, and if it's got some mixture of same and opposite, then you say it's neither. Okay? But first thing you're going to decide, is it quadratic? If you're going to do quadratic, then you're going to do what we did on the first slide here. Alright, so I'm just going to rewrite what it means to be even and what it means to be odd on the top of the screen here. Okay, so do a couple examples. So we'll say examples of finding symmetry, and they may just say that, and you need to decide whether it's quadratic or not. So f of x is equal to x to the 6th minus 5x to the 4th plus 12. And And we're going to plug negative x in, so we're going to replace each x with a negative x. Make sure you put those parentheses around. Okay. 6 negatives makes a positive. 5 negatives make a negative, plus 12. And we see that those are exactly the same. So for the same, that means it's even, and if it's even, that means it's symmetric with the y-axis. Okay, so let's look at another one. F of x is equal to negative 3x to the 7th plus 5x cubed. So f of negative x is equal to negative 3, parentheses, something to the 7th, plus 5, parentheses, 3. And we'll plug in negative x. 8 negatives makes a positive. So these are in fact opposite, but I meant to put a positive here. So if it's opposite, it's symmetric with the origin. So here you got negative 3 and positive 3, 5 and negative 5, so exactly the opposite. So this is symmetric with the origin. Okay. I think I've got a little bit more for you. So again, I'm just writing down what even and odd is again. So what if we do absolute value of x plus 7? So f of negative x is equal to absolute value of negative x plus 7. Absolute value makes you positive, so it gobbles up that negative sign. And you see that they are the same. And you know what this function looks like. It's the v function. V function symmetric with the y-axis. And the plus 7 just shifts it up 7 units. So this is an even symmetric with the y-axis. Okay. What if we have 3x cubed minus x plus 8? And plugging it in. And then you just got to be careful about keeping all those negative signs straight. So we got 3 of them in the first one, so we got negative left over, 2 in the second term, so that's positive. And we say this function is neither. So you see that we have 3x cubed and negative 3x cubed, so those are opposite. Negative x and plus x, those are opposite. 8 and 8 are the same, so we have a mix of same and opposite, so if that happens, then it's a neither function. Okay? And I think for good measure we should do one with a fraction. And the opposite of 1/2 is going to be negative 1/2. And what you'll notice is that the denominator is the same. It's only the numerator. Only the numerator is different. Then only the numerator is opposite. So if I have f of x equals 5x over x squared minus 9, f of negative x is equal to 5 times negative x over negative x squared minus 9. So you have a negative 5x over x squared minus 9. And we don't care about the denominator. We just want it to be the same. And the numerator is opposite. So if it's opposite, it's odd, and it has origin symmetry.